This one is the 2 dice rolled, and I told you guys to draw the array. So you have the array in that plastic sheet of paper. So go to your plastic sheet of paper to your array. And it says, what is the probability of rolling a sum greater than 8? If you haven't watched the podcast, you don't have this paper.
Got you there.
So there's the 2 die question where it asks, so I'm asking you for the probability of being greater than 8. So remember, these green options are all the different sums of the 6 by 6 dice, right? All the different sums. How many of them are greater than 8? Well, let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many? 36. Whenever it's a 6 by 6 die, it'll be out of 36. If it's a 4 by 4 die, how many would it be out of? 16. If it was a 6 and a 4 die, what would it be out of?
24.
24. We did good job. It would be out of 24 because you just multiply the outcomes, correct? And then you would get it because it's always going to be an array, and an array would be a something by something. And when it's a something by something, it's like an area, right? Something by something. 6 by 6, 36, right? So this one, we'd have 10 outcomes. So the probability, what? It just drew a really large blue line. I don't even know. Okay, let's go in here. So, if we have the 2 dice rolled, what's the probability of a sum greater than 8? So we do probability of sum greater than 8.
Do you have to write greater than 8, or can you use the greater than symbol?
If you use the proper symbol, I would just write sum greater than 8, because then it won't have a chance of oopsing.
Okay.
Now, if we have sum greater than 8, we always take whatever that is, find the number of those, over the number, what, every time? Total. Jeez, if I had a stamp right now, she would be getting it. Okay, number of the sum greater than 8 over the number total. So how many are greater than 8? How many of them were there? There was 10 out of?
36.
36, which I can take a 2 out of both, so it reduces to 5 over 18. Then we're going to flip over. All right. So we're going to try some questions. These are all junior high questions. So for the first one, number 2, it says, or for the person, I guess, number 1, it says 3-letter names. So how many names are there total? There's 10, Mrs. Lepp. Yes, there are. Good job. There are 10. How many of them are 3-letter names? 2. So we do 2 out of 10, or we'll always reduce it, or 1 out of 5. Okay, so it'd be a 1 out of 5 chance. If they ask you the probability in percent, you would have to take your answer and what? Nope. Times it by 100. Yes, you divide the 2 numbers and then times it by 100. So you go 2 divided by 10 times by 100, or 1 divided by 5 times by 100. So this would be 20% chance. So if it asks you for the percentage, you have to remember to take your answer and times it by 100. Okay, so you're going to try this out. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, all the way to 22. Try them out. These are junior high ones. Go. Okay, how many 4-letter words are there? 4-letter names. Yeah. There are 4 out of 10, which reduces to 2 over 5. How many names start with B? 2 out of 10, which reduces to
1 over 5.
1 over 5. How many names start with T? Trick question. Just kidding, that's not trick question. S is trick question. 1, Tina. Out of 10. 7-letter names? 1, Marilyn. Out of 10. Name starting with an S.
0 out of 10.
0 out of 10. So the answer would just be 0. Names ending in Y. 3 out of 10. Mary, Jenny, and Jerry. Okay. Then we have probability of a 2 out of all these. How many of them are there? There's 12. There's 1 out of 12 because there's 1, 2. How many 5s? 1 out of 12. How many J's?
2 out of 12 or 1, 6.
Or 1, 6. A number. 8 out of 12 or?
2 over 3.
You can divide them both by 4. A 4.
2.
2 out of 12, which reduces to?
1 over 6.
1 over 6. T's.
0.
0. 0 out of 12 or just 0. And letters,
4 out of 12.
which reduces to?
1/3.
1/3. All right. One card is drawn from a well-shuffled deck of 52. I love the well-shuffled. What is the probability of drawing an ace? How many aces? Out of? Which reduces to?
1/13.
1 out of 13. Face cards.
12 out of 52.
12 out of 52. Because there's 3 times 4, right? Because just king, jack, and queen and 4 suits, right?
Yeah, I just forgot to remember.
So we take 12 out and we get?
3 out of 13.
Yep. And a red 10? How many red 10s are there?
2.
2 out of 52, which reduces to?
1 out of 26.
1 out of 26. And then not a diamond?
39 out of 52.
Yeah, there's 39 not diamonds out of 52.
Are we, did I miss one?
Yep.
Oh, I included the Joker.
Oh,
in my, never mind.
okay, we reduce it to, she just wants,
That doesn't reduce.
No, because I.
she counted it as not a diamond. It does reduce.
It does.
I think I included one and an ace.
Yeah,
I counted one.
counted it twice.
Yeah.
So we go 39 out of 52 reduces to 3 out of 4.
Oh.
Which makes sense because it's 3/4 of the deck. Right?
What did you divide?
13.
Uh,
And you could go 39 divided by 52, math enter, and it'll reduce it for you as well. Your calculator's wonderful. It does crazy things. Remember, you can put every fraction in, and your math enter button reduces it for you. It's way better if you use your brain cells, but I'm okay if you're using an expensive calculator and getting money's worth. Okay. An even number. How many even numbers are on here?
4. out of
Yeah. 4 out of 8, which reduces to
half.
half. Multiples of 3 are just 3 and
2 out of
6, so it'd be 2 out of 8, which reduces to
1/4.
1/4. Prime numbers. 2, 3, 5,
7.
7. What's up, Kira?
Oh, no, I just thought I messed up.
You did. 1/2. I just messed up. And then 9s. How many 9s are on that spinner? None.
0.
Okay, we're going to flip over, and this one we're going to start 30-2. We're going to do odds in favor and odds against, so we're going to put on our thinking caps, okay? We're not going to take out our phones because that means we're probably not paying full attention. And the only time Mrs. Lepp calls on people randomly is when they're on their phones. So if you don't want to randomly be called on, don't be on your phone. I also will call on you randomly if I can tell you know what you're doing. If not, I'll prep you. I had one student who I'm friends with and play volleyball with, and she's like, it was always good because you always prep me, because she was also scared to answer questions because she didn't know what she was doing. So I'd be like, okay, so the prime numbers are not 1, but 2, 3, 5, and 7. So, and then I'd be like, Maddie, what are the prime numbers? She'd be like, 2, 3, 5, and 7. I'd be like, thank you very much. I just prep her with the answer beforehand. Didn't matter. She just had to pay attention. Worked out well. Okay, so we're going to go here. Compliment. What's a compliment? We've already learned about compliment.
It's not.
Something is not. So if I give you like snow, you tell me the compliment is?
Rain.
Not snow, which could be rain, grass. Sure. Those are all options I've never been given before, but I will agree with that. Okay, so.
Watermelon. Snow's watermelon.
Yeah. So the complement of snow, the easiest description would be not snowing. Yes. Okay. So this one says, if we have an event such as picking a heart from a standard deck of cards, the complement of picking a heart would be does not pick a heart or not picking a heart, right? Okay, let's think about this. So if I said, this is just me on the side, if I said picking a heart, how many hearts are there? 13. And then if I said, how many not hearts are there? You'd say?
Not 13.
Not 13, which would be 39. Because what should they add up to? They should add up to the total, right? To 52. Okay? But what happens if we deal with probabilities? We dealt with that before. We've dealt with complements. We did that before. But what happens now if we do probabilities? So the probability of a heart. The probability of a heart is 13 out of 52, which is a quarter. Correct? So what's the probability of it not being a heart? Be 39 out of 52, which is 3 quarters. Okay? So if I take those two, 1 quarter and 3 quarters, what do they add to? 1. They add to 4 over 4, or 1. So what can we say about complementary events and their probabilities? They should add up to 1. Exactly. You get a sticker. No one asked that last class. Get a sticker. Okay. So complementary events should add to 1. Should add to 1. Remember, ate it. Okay. So they should add to 1. So if I gave you, let's go on to a side note, not probability of hearts anymore. Let's do the probability of, let's pretend the probability of snowing tomorrow. Probability of snowing tomorrow, let's pretend, is 0.94. That would suck if that was true, because that'd be a 94% chance it's going to snow tomorrow, which I really hope isn't going to happen. That's just evil. Okay? So what would the probability of not snowing then be? 0.06. What did you do to get that? You took 1 and then, yeah, super smart, big brain. 1 minus the probability that it was going to snow, right? That's all you did. So you went 1 minus 0.94, and you gave me 0.06, right? So if we say this, for any event A, P of A plus P of the complement of A, the probability of A plus the complement of A should equal what? What did we say? Should equal what? The probability should equal 1. So then I said, well, what if I want it not happening? What's the probability of it not happening? Well, I could do 1 minus the probability of it happening, right? And what would be left over is the probability of it not happening. It's just rearranging this formula. If I want P of not A and I have P of A, I can just take 1 minus P of A and I get P of the complement, right? So let's go down here. Suppose that event A has the probability of 3/8. 3 out of 8. What is the probability of event A not happening? Of not A happening? What would I do? Yeah, because what did you do? You went 1 minus 3/8, which is 5 out of 8. Which you can type in your calculator and it'll give the answer to you. Or you visualized 1 is 8 over 8, right, Robbie? And you went 8 minus 3, which is 5. Yeah. You guys try number 2. So Robbie had a good point. Fractional probabilities and decimal probabilities add to 1, correct? But if your probability is actually in a percent, what should it add to? 100. That's the difference. So if your probability was given in a percent instead, like if the percent of it snowing tomorrow was 58%, then we would have to add them to 100 instead of 1, right? Okay. So suppose the probability of it snowing, I always write it out so I can see it, is 0.58. Then what's the probability it will not snow? Well, probability of not snow will be 1 minus the probability of it snowing. I'm just showing out the long term. You don't have to. And so it's going to be 1 minus 0.58, which is
0.42.
0.42. So here we have the Saskatchewan Rough Riders were given a 25% chance of winning the Grey Cup. This kills me that this is written that way because I'm from Saskatchewan, but whatever. I'll deal with it. It's kind of accurate sometimes. Pardon? It's true. It's true. Some years this is accurate, and some years this is not accurate. So what is the probability of the Rough Riders winning the Grey Cup that year when they sucked, which they normally don't? Just saying. So what's the probability of them winning?
1/4, 1/5.
Yeah, how'd you do that? You went 25 out of,
100.
which reduced to 1 out of 4. So they have a 1 in 4 chance of winning that year because they weren't the greatest team. It was the year they put 6 men on. Yeah, kind of went a little lower. Okay. What is the probability of the Rough Riders not winning the Grey Cup as a fraction? 3 out of 4, but how'd you do that? You just said, well, if it's winning is 1 out of 4, then not winning would be 3 out of 4. Because they should add to 1. Exactly, using the rules we used in the previous part, right? Okay, now we're going to do odds in favor, odds against. Can you grab out your extra sheet of paper? The one that was in the plastic sleeve. If you don't have one, I'm going to give you one. Not strawberry, no. Not just strawberry. Okay, so we're going to put odds in favor and odds against on this sheet. So on this sheet, you're going to have odds in favor. This is the sheet that you had in the plastic sleeve. You're going to take it out of the plastic sleeve and you're going to write odds in favor. Yeah. Oh, yes, Verna. You didn't even ask for the new notes, Verna. Oh, I gave them to you. I was like so smart about that yesterday. I remember now. I gave them to you. No. Okay, odds in favor. So, paying attention. Odds in favor if I go. Odds in favor of, let's pretend I say winning. We're going to go back to where we were. So I say odds in favor of winning. Whenever I use odds in favor, whatever comes after odds in favor comes first, which will make sense in a second. So whatever comes after odds in favor comes first. Odds in favor first. Okay? I'm going to use an example for this. Odds in favor comes first. So I say odds in favor of winning. Now I have odds. Odds means I have 2 dots, right? That's odds. What came after odds in favor?
No.
No, what comes after? Odds in favor of winning. Winning came after it. So winning is going to come first. So what's going to come after that?
Losing.
Losing, or the complement which we would say not winning. Now you can't say the complement of winning is actually losing because there can be ties, right? So if we used winning, we would use not winning because that could include losing and ties. Okay? So it's odds in favor. Whatever comes after it comes first. Then we'll have odds against is my other one. Odds against, let's say, winning. When we use odds against, whatever comes after odds against comes second. So now I have odds against winning. So winning will come second, and not winning will come first. This is something to note. Odds always add to the total. And where is the total always found? On a probability. Where's the total always found? On the, where do you put the total? In the denominator. So odds always add to the total, and the total is always the denominator of the probability. Then you can put your sheet back in your plastic sleeve. And then we're going to go back a page. Well, or you're going to go back to your page. I'm going to go back to a page. So here we have, ready? What are the, now we have to read, odds in favor. Whatever comes after odds in favor comes first. 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 So what comes after odds in favor? Odds of favor of winning the Grey Cup. So I'm going to have winning come first, and then not winning come second. So how many times did they win? Let's go above. 1 out of 4. How many times did they lose or not win?
3 out of 4.
3 out of 4. So how many times did they win? 1. And how many times did they lose or not win? Sorry, 3. And what do these total up to? 4. They should total. Your odds should total to the denominator of the probability, correct? Because your odds always equal total. So I know I'm right if I say, okay, 1 plus 3 equals 4. Yes. They should always add to the denominator of your probability. That's what you need to check. Because what they can do on the diploma is they can give you probability and ask for odds. They can give you odds and ask for probabilities. And you have to be able to interchange and know. So your odds will always give you the denominator of your probability. Your odds will give you the denominator of your probability. So here we have odds against. When it says odds against, it comes second. Odds in favor first. Odds against second. Odds in favor first. Odds against second. So what comes after it? Odds against winning. So winning is going to come second, and not winning is going to come first. How many times did they not win? 3. How many times did they win? 1. What is this total to? 3 plus 1 equals 4. Yes, we're good. Okay? All right. Now what we're going to do, you're just going to pay attention. You're going to answer me. Can't write on here. I don't know why I'm erasing this. Like it's being recorded. But there we go. Erased. So you don't have to write this down unless you want to. You're going to need a separate sheet of paper if you do. But it's up to you. I'm going to give you the probability. You don't have to write it. You can pay attention. If you want to write it, you can. The probability it will snow tomorrow is 0.31. Made it a little bit lower. Okay? That's all I'm giving you. Now I can ask you so many questions. That's all I'm giving you. Ready? Okay, my first question is going to be odds against snow tomorrow. What's the first thing I'm going to want to do to this? turn it to a fraction. So the probability of snow is going to be, how do I turn it to a fraction?
Math enter.
You can go math, enter, enter. You can take the decimal, turn it into a fraction. Go do it. Everyone needs to. It's not just me. Not just Julia. Everyone.
Do you have to reduce the fraction, or you can just leave it as?
When you do math, enter, enter, it reduces it for you.
Oh, so you just leave it at 30.
Yeah. So you can either go 31 divided by 100, or you can go 0.31 math, enter, enter, which gives you 31 out of 100. So before I go and do any questions, this is what I always do. I turn my probability of snow into a fraction, and then I can get what else right away?
Not snow.
Probability of not snow. How do I do that?
1 minus
1 minus that. Or what supplements give me 100, right? So it's going to be
100.
out of
100.
100. Okay, now, sorry. Now, we're going to go, it's serious. And do you know how many times stupid fundamental counting principles come out as 420? All the time. It's just not meant to, it's just bad. All right. This I did it. All right. What's the odds against snow tomorrow? Odds against snow tomorrow.
31.
We go odds against, and then whatever comes after it comes
Second.
second. So snow is second, and
Not snow.
not snow is first. How many times did it not snow?
69.
And how many times does it snow?
31.
31. It's a real problem. All right. What does that total to?
100.
100. I can't believe I did that even reading after saying I'm such an idiot. Okay. So, it totals to 100. It's like subconscious. It's messed up. All right. Now, odds in favor of not snowing. Odds in favor of not snowing. Odds in favor, what comes after it comes?
Right.
And what is it? So what actually is it? I just gave you the exact same question, didn't I? Just worded differently. That's all I did. Okay? One more thing. I'm going to give you this now. This is my challenger. You guys are going to answer it. Not out loud. You're going to try it on your own. Here's my challenger. Odds in favor of Mrs. Lepp winning the lottery.
0.
I believe in myself a lot better than you. I don't buy lottery tickets, so it really is a 0, but that's okay.
Can we write this down?
Yeah, sure, if you want to. It's up to you. Odds in favor of Mrs. Lepp winning the lottery
Or just do it?
is 88 to 1.
That's good. Okay.
Previous to this lesson, you wouldn't have known if that was good or bad. And you might still be in that boat. We hope you're not. Okay, odds in favor of Mrs. Lepp winning the lottery is 88 to 1. I want you to give me the probability in your head, not out loud. Probability of Mrs. Lepp not winning the lottery. You're going to figure that out in your head. In your head, in your head. What do you think, Tyler? That doesn't sound like an answer, does it?
No.
Wait till the answer, sir. All right. Anyone know the probability of Mrs. Lepp not winning? Keep her.
28.
Nope. Yep.
Is it 1 out of 100?
Nope. Yep.
0.01.
Nope. Probability. Okay, let's go. Odds in favor of Mrs. Lepp winning. What is the 88? What is it?
Winning.
Winning. What's the 1?
Losing. Not winning.
Not winning. Okay. So you guys got the 1 part down. So the probability of not winning, you got the 1 part down. Rubleski? 1 out of 89.
What?
What's the bottom of your probability always? The total. And what's the total on an odds? The 2. The 2 added. The 2 added always become the what? The denominator. 88 plus 1 equals 89, which is always my denominator. So it's 1 out of 89. What's the probability that Mrs. Lepp will win the lottery? If only this were true. 88 out of 89. So when you go from odds to probability, pay attention, when you go from odds to probability, these numbers in the odds will always be the what of the fraction? Each one of these separately will be the what? The numerator, and those together will be the denominator, right? Each one of these will be the numerator. These together will be the denominator. So if I ask for the probability of winning, it will be 88 over 88 plus 1. The probability of not winning, it'll be 1 over 88 plus 1. Okay? Got it? We're actually done early. Quite a bit.